So, what happens when you smash together two of the most powerful technologies we've ever imagined, artificial intelligence and quantum computing? Well, we're not just talking about an upgrade, we're talking about a full-blown technological revolution. And we're about to break down exactly how it's all going to unfold.
All right, so to really get this, you have to see the evolution of AI in three big phases. First, you've got ANI, or artificial narrow intelligence. That's the specialized AI we have right now. Then the next big goal is AGI, artificial general intelligence, which is an AI that can think flexibly, like a human. And finally, the ultimate frontier, ASI, or artificial superintelligence, an intellect so vast that we would be to it what an ant is to us. We're going to walk through this incredible journey and see how quantum computing is basically the key that unlocks every single stage.
Okay, here's our game plan. We're going to start with the AI we all know, ANI, and see how quantum is already giving it a massive boost. Then we'll peek over the horizon at how AGI that's built, and finally, we'll get into the truly mind-bending stuff with ASI. So let's kick things off with the here and now.
All right, let's start with today. For the AI we have right now, what we call artificial narrow intelligence, you have to understand that quantum computing isn't just a speed boost. It's not just about faster calculations. No, it's a total game changer, fundamentally shifting the kinds of problems AI can even think about solving.
So you might be wondering, how does it actually do that? Well, it really boils down to four key things. We're talking explosive optimization, much deeper pattern recognition, way more efficient machine learning, and the ability to create incredibly high-quality simulation data. Let's dig into each one. First up, optimization. Just imagine a massive delivery company trying to figure out the best routes for all its trucks. A normal computer has to go through the options one by one. It's like trying every single key on a giant keychain. It's a nightmare. But a quantum computer? Thanks to this wild idea called superposition, it's like it can try all the keys on the ring at the exact same time. It checks all the possibilities at once to find the one perfect solution, almost instantly. A problem that took hours or days is now solved in seconds. Second, pattern recognition. And this is where it gets kind of spooky, in a good way. Quantum lets AI see connections that are literally invisible to us and our best computers. It can take data and map it into these huge complex spaces, allowing it to spot things that are incredibly subtle, like a tiny signal of a complex financial fraud or the absolute earliest signs of a disease.
This table really sums it up perfectly. It's not just about being faster, it's a huge leap from finding a good enough answer to finding the actual best answer. And get this, it can often do it with less data, because it's so much better at pulling out the deep, meaningful information that's already there.
Okay, let's level up. Part 2, Forging General Intelligence. This is AGI. We're talking about the quest to build an AI that can reason, learn, and just understand the world the way we do. And this is the point where quantum computing stops being just a useful tool and starts becoming part of the AI's core architecture, part of its brain, really.
A lot of researchers in this field believe that for an AI to achieve real human-like intelligence, it can't just be a data crunching machine. It can't just be a pattern finder. It needs a totally new foundation, something that lets it understand the world in a more intuitive, fundamental way, almost like it understands the laws of physics. And for a lot of them, quantum computing is that exact missing piece.
Now, this is where things get really mind-bending. Think about how a normal AI finds an answer. It's like a ball rolling across a bumpy landscape of possibilities, and it usually just settles in the first decent-sized valley it finds, a good enough solution. But a quantum AGI can use this bizarre trick called quantum tunneling. Instead of having to roll up and over the next hill, it can just pass straight through it to find the absolute deepest valley, the best possible answer. It's like a cheat code for problem solving, and it's absolutely crucial for building real common sense. So for an AGI to really get the world, it needs to build a unified world model. It has to connect everything. And another quantum superpower, called entanglement, is perfect for this. It's like having two coins that are magically linked. If one is heads, you know the other is instantly tails, no matter how far apart they are. A quantum AGI could use that same idea to instantly link totally different concepts, like the word apple, the taste of an apple, the physics of an apple falling from a tree, and what apples mean in our culture, all in one go. That's how you get true understanding.
All right, buckle up. We're now heading straight into science fiction territory. Part 3, Artificial Superintelligence, or ASI. This is an intelligence so far beyond human intellect, it's hard to even wrap our heads around it. And at this stage, quantum computing isn't just a helper anymore. It becomes the engine for an intelligence explosion.
So what makes an ASI? Well, super. It's this one core concept: recursive self-improvement. An AI that can look at its own source code, find ways to make itself smarter, and then literally rebuild itself into a better version. And then it does it again, and again, and again, getting exponentially smarter with each loop.
And here is the absolute kicker: the speed. For a classical computer to run just one of these self-improvement cycles, it could take tens of thousands of years. A quantum ASI? It could do it in a few seconds. Just think about that for a moment. That's millions of years of evolution happening in the time it takes you to check your email. Because this new intelligence would literally be thinking in the native language of the universe, quantum mechanics. It could start to simulate and then manipulate matter itself. And I'm not just talking theory. I'm talking about inventing totally new materials on the fly, reprogramming our DNA to cure disease or stop aging, maybe even creating food directly from the air.
And why stop there? An ASI could take on the ultimate optimization problem: planet Earth. Imagine an intelligence that could manage all of our planet's resources, our climate and our energy grid with perfect efficiency. It could solve the equation for 100% sustainability, pretty much guaranteeing the long-term survival of our species.
Of course, an intelligence this powerful would completely redefine security. On the one hand, it could shatter every form of encryption we have today in a heartbeat. But on the other, it could create its own fortress, a perfectly unhackable quantum communication network, and place its own core intelligence inside, totally safe from any outside threat.
Okay, let's bring it all together. We've gone on a huge journey from the AI we have today all the way to a future that's hard to imagine. And as we've seen, the partnership between AI and quantum computing isn't just one thing. It evolves. The role quantum plays grows dramatically, from being a specialized tool to being a core component to becoming the very fabric of reality itself. This final chart really is the key takeaway. For today's narrow AI, quantum is a supercharger for specific tasks. For tomorrow's general AI, it becomes the architectural foundation that allows it to build that true world model. And for the future's superintelligence, it becomes the engine for actually reconstructing physical reality, drawing creativity straight from the fundamental laws of physics.
And that leaves us with one final provocative question to chew on. If an intelligence can completely master the laws of physics that govern our universe, what's to stop it from one day deciding to change them? What would that even look like? Just something to think about. Thanks for watching.